Good evening, everybody. Welcome once again to another exciting edition of our Jamb Quest to Conquer. It's once again a pleasure to have you here joining me live. I remain your host, Mr. Femi. And today, on the platform of your study part, we are bringing to you topics for which you should get yourself familiarized with in your JAMB examination preparation. So, to begin with, we want to take our mind back to how we plan the schedule of the class running till around March or April for next year when you are going to be writing the examination. We said it's going to be an instance whereby we pick various topics from your physics. And if you could remember last week, we focused on electricity as a branch of physics, which you are popularly asked in your examination. Looking closely, you discover that what? Under that aspect, we focus on the topic current electricity. Current electricity, we hammered on the various formulas, the various question forms, which comes out under current electricity. Today, I have brought to you good tidings because we'll be looking at another interesting aspect, branch of physics, which is actually what? Heat and temperature. So we'll be looking at topics under heat and temperature for which we have questions coming out from. So I'll be linking them all under this heading. We'll be looking at questions that relate to specific heat capacity. We'll be looking at linear expansivity. We'll be looking at things as it relates to temperature, and heat, among other topics that would what ensue along the line. So you might have your mode of heat transfer as well. So the focus would be, what do we have under these aspects that would what appeal towards the audience of knowledge which we want to acquire in our JAMB examination. Specific capacity. When we have specific capacity, we'll be making reference to certain formulas. Number one, we want to understand the various conversion rates in terms of energy that is actually what's produced or converted when you're having ice melt into water, or you have water being converted to steam, or you have steam being cooled down to water. So what happens in this instance? We have this. Number one, we talk about heat energy. You should know you could be asked to calculate heat energy, alphabet Q, which is under the formula MC change in theta, or you have ML, where the L is the latent heat, C is specific heat capacity, and you have L as latent heat, either of fusion or of vaporization. Now, not forgetting the conversion ratio under heat and making reference to heat loss being equal to heat gain. Let's work with that. Heat loss equal to heat gain. Also, you have that energy conversion such that heat energy is equal to electrical energy and can also be equal to kinetic or potential energy. We can have, with respect to the linear expansivity part, okay, let's take it as expansivity part rather than linear. Let's have it as the general approach of expansivity, expansion, expansivity. So under this, we have the linear expansivity alpha is equal to L2 minus L1 over L1 into brackets theta 2 minus theta 1. We have that area expansivity beta is equal to A2 minus A1 over A1, then you have bracket open, theta 2 minus theta 1. Furthermore, we have that area expansivity, or we call it superficial expansivity. Area expansivity or superficial expansivity. Volume expansivity, volumetric or cubic expansivity. We have it that gamma equals V2 minus V1 over V1 theta 2 minus theta 1. So we'll be looking at this where we have that gamma is equal to 3 alpha, beta is equal to 2 alpha, and gamma is 3 over 2 beta. So put that in mind, that we have certain things within the role of these aspects. So let's look at some of them. Specific heat capacity, expansivity, heat and temperature, as well as mode of heat transfer. So what do we have under this aspect? It's for you to understand that specific heat capacity is talking about the amount of energy needed to raise a unit mass of a substance through 1 Kelvin. It's actually the amount of heat energy needed to raise the temperature of a substance, of a unit mass of a substance, through 1 Kelvin. Note that whenever we make reference to specific heat capacity, we want to raise, we are talking about the amount of energy needed to raise a unit mass. You don't throw that away. Because why? Specific heat capacity is actually what? In relation to a unit mass. We have another tag, heat capacity. Heat capacity is actually forming the product of a quantity of mass and the specific heat capacity that what it can acquire. That's why if you're asked to define heat capacity, you use the word that what? It is the amount of heat energy required to raise the temperature of a given mass. The mass can be any value, but when you are making reference to specific capacity, you are talking about 1 kg, just 1 unit of the mass of the substance. When you are raising the temperature of a given mass, you are making reference to heat capacity. Note that. So having that been cleared out of the way, you should understand that what? When we make reference to latent heat, which is alphabet L, you can have latent heat of fusion, and that's where you see them label LF, or you have latent heat of vaporization, which is LV. Latent heat of fusion, or you are making reference to latent heat of vaporization. What is the difference between two? Take your mind back to something fusing. When we want to have a change of state such that water fuses into ice, when a liquid changes into its solid state, then what happens is latent heat of fusion taking effect. Note, the amount of heat energy needed to what? Change and convert the state of what? A substance from its liquid state to its solid state. and vice versa. From solid state to what? Liquid state is what we tag latent heat of fusion. And take, for example, when we make reference to water, one thing is peculiar about water to ice. We say that it will always occur at 0 degrees Celsius. The conversion of water into ice would always take place at what? 0 degrees Celsius. Everything about the water is converted into ice exactly at 0 degrees Celsius. There's no rise in temperature at that instance. Similarly, when ice is converted to water, it takes place at 0 degrees Celsius. Note, there's no change in temperature. That's why when you have what? Your drink, which you just took out from the fridge, what happens is very simple. You place it on your table, and it is expected of you to know as a science student that the ice block, the drink, the freeze drink begins to melt. The melting process such that what? The ice content in it reducing all takes place at what? 0 degrees Celsius. The continuous melting instance is occurring at 0 degrees Celsius. Have that at the back of your mind. It is when you have all the ice block traces inside that drink melting completely, that is when there's now going to be an increase in temperature. So don't deceive yourself to say that what? Oh, the drink which I placed on my table, although having small mass of what? Ice block in it, is actually what? Increasing in temperature. No, you'll be wrong to say that. All the heat acquired at that instance where you have your ice block still visible is actually used to melt the ice. Note that the amount of heat that what is absorbed by that what? Ice block in order to melt it is what we call the latent heat of fusion. Latent heat of fusion. When we make reference to what? Latent heat of vaporization, which is the second form of what? Latent heat. Latent heat of vaporization. We are talking about L subscript V. And this will occur when we are making reference to what? Water converted to steam. And what temperature does that occur? 100 degrees Celsius. 100 degrees Celsius. We're talking about the instance whereby water can be converted into its gaseous state from liquid to what? Gas form. So in that instance, when a substance is converted from its liquid state to its solid state, to its gaseous state, then we say that what? Latent heat of vaporization is needed in that instance. Water to steam, latent heat of vaporization. So it means that when you are what? Boiling your water, the water keeps on boiling and you have some amount of heat changing into steam continually. As long as you have that what? Water is still present inside that pot, then it means that what? You still have what? The temperature at 100 degrees Celsius. All the heat collected by what? That quantity of water in the pot is needed to convert what? The state of the water into what? Its gaseous state, which is steam. So latent heat of vaporization. So we should clear our doubt. You should know that what? Whenever we are talking about temperature increase, whenever we are making reference to temperature increase and you are asked to calculate heat energy, the formula remains Q equals MC change in theta. Whenever it has to do with what? Increase in temperature, and you are asked to calculate heat energy, this is what you are using. MC change in theta. Whenever you are asked to calculate what? Heat energy with reference to change of state, whether you are having what? Water converted to ice, ice converted to water, or water to steam, steam to water, then you know that what? Q must be equal to ml. Q must be equal to ml. Also have it at the back of your mind that we should not run away from the fact that there's a phenomenon which takes place anytime you are talking about what? Temperature, among other things, which we are going to get to. But before then, understand that what? We can have mixture of hotter body and what? Colder body. When we have mixture of, for example, hot water and cold water, then we'll talk about heat loss being equal to heat gain. You want to have your bath in the morning and you have that the water is too cold for you. What happens? Naturally, you boil your water to a certain degree. Then what happens? You mix them together. When you're having what? Mixture such that what? A body is more hotter than the other, you have that what? You are going to work with heat loss by the hot body being equal to heat gained by the colder body. Now, furthermore, you can always have that what? Energy conversion taking place under specific heat capacity. And what do we focus on talking about your Jamb examination? You should know that what? It's expected of you to know that whenever we talk about you boiling water, you can have it that what? You are making use of what? Your electric boiler, such that electric energy becomes converted into heat energy. You are using your boiling ring, for example. You plug it to electric source, and what happens? Electricity becomes converted into what? Its form of energy. So we can relate the two. You can talk about what? Kinetic energy or potential energy of a waterfall producing what? A form of heat energy, such that what? We can have mgh, formula for potential energy, being equal to what? MC change in theta, which is what? Heat energy. Don't worry. It's not to bore you with too much information. You see us put it into prospect when we start solving our questions. But have it at the back of your mind that what? These are basic fundamental things we adopt. Furthermore, it's also for you to note that what? We can make reference to what? Expansivity. What is expansivity? You talk about what? An increase in size of what? A body per unit what? Rise in temperature. And what? A fractional increase. Let me put it that way. A fractional increase in the size of what? A body, what? Per unit rise in temperature. So fractional in the sense that what? There's a change in the value of the size, either in terms of its length or in terms of its area or in terms of its volume. That's why we are having linear, area, and cubic expansivity. So subject to what? The three dimensions for which the size can change, we have that what? Expansivity takes effect. So generally speaking, when they ask you to define expansivity, you know you are focusing on the fact that it is the change in size. The size can be the length, it can be the area, or it can be the volume. That being said, three formulas to adopt making reference to what? Expansivity. First, linear expansivity. We have that what? The formula for linear expansivity is such that what? L2, the new length minus the original length divided by the original length times change in temperature. If you are working with area expansivity, or we also call it in our UTME examination, superficial expansivity, have it at the back of your mind. We don't only call it what? Area expansivity, we also address it as superficial expansivity. Once addressed as superficial expansivity, we have that beta becomes equal to A2 minus A1 over A1 change in temperature. Finally, volume or cubic expansivity, we have that gamma, which is denoted by the Y symbol, becomes equal to V2 minus V1 over V1 change in temperature. We have heat and temperature, where you are going to be looking at what? Various forms of thermometer and the questions that are embedded in them. Maybe with regards to temperature scale, converting from one temperature scale to another. So we'll be looking at all these and more. Let's get right into business. Remember, not too much information outside the scope of what? Your UTME past question. We hit the nail on the head looking at past questions series, questions that what relate to such topics. So first on the list, this question has this to say. Number one, calculate the energy required to raise the temperature of a liquid of mass 15 kg from 50 degrees Celsius to 100 degrees Celsius. We are given specific heat capacity of the liquid to be equal to 960 joule per kilogram per Kelvin. So this is the question. Let's see what we can make of this question. Calculating the specific heat capacity. So how do we go about this? We focus on the parameters given. We have identified that the energy is what we're asked to find, Q. The rising temperature, which is theta 2 minus theta 1, would be 100 minus 50, which gives rise to 50 degrees Celsius. We have our mass being 15 kilogram, and we have the specific heat capacity also denoted by alphabet C as 960 joule per kilogram per Kelvin. So working with this, we say that Q equals MC change in theta. Just slotting your values, being 15 multiplied by 960 multiplied by 50. And there you have your answer. The product of 15 times 960 multiplied by 50, which is 72,000. Q becomes equal to 720,000. 720,000. You can see it in standard form, which will be expressed as 7.2 times 10 raised to power 5 joules. That becomes the value. So nothing much in terms of being a big deal. It's just for you to look at the parameters given. And you see, we are good to go solving the first question. Oh, let's look at the next question quickly. Question 2. Question 2. For question 2, under energy conversion, question 2 with regards to energy conversion, we have this. Question 2. A block of aluminium of mass M is heated electrically by 25 watt heater. Full stop. If the temperature rises by 10 degrees Celsius in 5 minutes, calculate the heat capacity of the aluminium. And someone will look at this question and will be like, oh, there's something wrong with this question. How come they are making reference to heat capacity and mass is not given? Yes, they can ask you to calculate heat capacity. Remember at the intro of this class, I said heat capacity is a product of your specific heat capacity and the mass. The product of your specific heat capacity, alphabet C, and the mass is what we call heat capacity. They are not asking us to calculate the specific heat capacity. Specific means that we are using 1 unit of mass, 1 kilogram of mass. But here now, for its capacity, it can be any value of mass.